Let's take a look at example 3e. Use the rules of exponents to simplify the expression. Assume all variables represent positive values. In this example, we have a complicated quotient being raised to the negative 3/5 power, and we are being asked to simplify this expression. In our quotient, we have a times b to the negative 1/4 in the numerator, and a raised to the negative 1/3 times b to the second times a to the 8/3 in the denominator. And again, that whole quotient being raised to the negative 3/5 power. Now there are several ways to approach a complicated expression such as this. The key is to use our rules for exponents that we had for integers and go step by step. Now, different people may use different processes or different rules at different times, but so long as you go step by step, you should be okay. Alright, so the first thing that I like to do is I like to simplify what's inside my quotient first before I deal with my negative exponent on the outside. And on the inside, I notice that I have two factors of a here in the denominator, a to the negative 1/3 and a to the 8/3. And so my first step is going to be to combine these two together in the denominator. To do that, I want to use the rule that tells us what to do when we have two bases being multiplied together. That rule is the product rule, and it tells us that when we have two bases being multiplied together, we can combine into a single base by adding the exponents. So I'm going to add the exponents together to get a single base of a. And let me just do that right here. I have a to the negative 1/3, and I'm adding to it, because I'm multiplying the bases, the exponent 8/3. And luckily it's the same denominator, so we can simply add across. So this is simply, when I combine these two factors together, a to the 7/3. Negative 1 plus 8 is a to the 7/3. So let's put this together. This expression becomes a times b to the negative 1/4 all over, and now we've combined these two a's together to get a to the 7/3 times b to the second power, and that entire quotient is being raised to the negative 3/5 power. Alright, so far we have several options here. Again, I want to continue simplifying the quotient. And I note this time that I have two bases that are being divided. When you have two bases that are being divided, we want to use the quotient rule for exponents. The quotient rule for exponents tells us that when we have two like bases that are being divided, we can combine them by subtracting the exponents. So let's apply that to the a's right here, these two a's right here. Now this is a to the first power, and this is a to the 7/3, and using the quotient rule, I would be subtracting, so I would have a to the 1 minus 7/3. But how do we do this? Well, 1 is equivalent to 3/3, correct? So this is just a to the 3/3 minus 7/3. We must have a common denominator when subtracting fractions. And 3/3 minus 7/3 is simply negative 4/3. So when I combine the two a's using the quotient rule, I'm going to get a to the negative 4/3. Before I put that back into my problem, let me also talk about putting the b's together. Now the b's get combined also using the quotient rule. Quotient rule says subtract the exponents. So the b's, we're going to put the b's together, right, by subtracting the exponents. So I have b to the negative 1/4 minus 2, which I'll write as 2 over 1. Again, in order to subtract fractions, we need a common denominator. I have a 4, so I need to change this into 4, and I do that by multiplying both numerator and denominator by 4. And so this simply becomes b to the negative 1/4 minus 8/4, and combining still, I have b, and when I subtract, negative 1 minus 8 will give me negative 9/4. And so using the quotient rule, these b's will become b to the negative 9/4 power. So let's put this all together, and that then tells us that we have this expression being equal to a to the negative 4/3, b to the negative 9/4, all being raised to the negative 3/5 power. Perfect so far. This is much simpler than this. Let's keep going. We want to use now the rule that says when you have a product within a power, you can distribute the power to each of the factors that are inside. That's one of our power rules. The second power rule tells us that if we have a product raised to a power, we can take each factor and raise it to that power. So I'm going to take a to the negative 4/3 and raise it to the power negative 3/5. And that's going to give me a raised to the negative 4/3, all raised to the negative 3/5 power. Similarly, I can take b raised to the power here and raise it to the exterior power negative 3/5. So that gives me b raised to the negative 9/4, all raised to the negative 3/5 power. We can finish this example by now applying the other power rule. That is, when you have a base raised to a power, we multiply the powers. A base raised to a power is the same as the base raised to the product of those powers. So that gives us a raised to the negative 4/3 to the negative 3/5 is equivalent to a to the negative 4/3 times negative 3/5. And b raised to the negative 9/4 raised to the negative 3/5 is equivalent to b raised to the negative 9/4 times negative 3/5. And simplifying and putting this all together, we get that a to the negative 4/3 times negative 3/5, when we perform the multiplication, we first cancel our 3's from numerator and denominator and then multiply across. So that gives us a raised to the negative 4 times negative 1, which is just positive 4, over 1 times 5, which is 5. So a raised to the 4/5. b, here there's nothing to cancel because the 9 and the 5, the 3 and the 5, the 3 and the 4, the 9 and the 4 have no common factors, numerator or denominator, so we multiply straight across. Negative 9 times negative 3 is 27. 4 times 5 is 20. That completes our problem. That's as far as we can simplify. This expression here simplifies down to a to the a to the 4/5 times b to the 27/20. The moral of the story is, go slow, apply your exponent rules step by step, and you should arrive at a simplified answer. Let me finish by giving you a summary page of basic exponent rules and definitions. These rules and definitions will help you as you simplify expressions involving rational exponents. Write all of these rules down: the product rule, quotient rule, power rules. zero exponent, negative exponents, and negative exponents in fractions rules. They will all help you as you go about doing your homework exercises. Good luck!